Good day children, welcome back. In today's session, we're going to start new chapter. Can you guess what topic are we going to deal with? Yes. Now look at the figure. Delhi records the hottest day in 20 years. Biggest fall in Sensex in 5 years. RD scores fastest century in one-day cricket history. India's population to overtake China by 20 to 30. You must have heard or seen the headlines in newspaper. Have you ever wondered what makes such headline possible? These headlines are possible only because of some people, some organization continuously maintaining a record quantity by stating temperature of different cities, the rise and fall of Sensex, scores of different batsmen and the population of India. The systematic record of fact of different values of quantity is called data. An analysis of data can give us many different kinds of information. Yes, in today's topic, we're going to learn about statistics. In statistics, in your lower classes you would have studied, it is nothing but collection of data, classification, tabulation, analysis and interpretation of data. In lower level, you studied only mean, median and mode. But in the higher level, we are going to see ahead, one step ahead. In this, statistics can be varied into three types. One is data. Second one is we'll be seeing measures of central tendency. Measures of central tendency is nothing but mean, median and mode. And third one is measures of dispersion. And the measures of dispersion we will be seeing range, mean deviation, quartile deviation and standard deviation. So in today's class also we're going to start with mean deviation. Now let us start the session.
Welcome to the lesson on the collection and presentation of data. Data is continuously being collected all around us through scientific experiments, opinion polls, election results, satellite images, and much more. Even your report card is just a collection of data about your year-round performance. All this data not only helps us keep track of current happenings and trends, but also helps us predict what might happen in the future. The school authority wants to deploy a school bus for their students coming from a particular locality. Our friend here is assigned a project to find out how many children in the school come from that locality. Now, how would he collect this data? One way to collect this data is that he personally speaks to every child in each class to find out where that child lives. The data collected personally by him is called primary data. Primary data can be collected through questionnaires, interviews, observations, case studies, portfolios, etc. It is quite difficult and time-consuming. A far easier way for our friend would be to approach the school authorities and get the names and addresses of students coming from that particular locality. The data gathered from a source where it already exists is called secondary data. You can see that collecting secondary data is far easier than collecting primary data. Mrs. and Mr. Longlife are both in their 90s. And they have a happy joint family. A rather large happy joint family. Let us look at the ages of all the members in this family. It would be interesting. As you can see, the data of ages of the different members of Mr. Longlife's family is quite an interesting mix. Can you notice the ages of the oldest and youngest members of the family? Let us see if we can present the data to make this observation easier. We can make the observation of highest and lowest values in given data easier by simply arranging the data in ascending or descending order. Here, we have arranged the ages of Mr. Longlife's family members in descending order. The highest and lowest values in the given data are of special importance. The difference between them gives a number that is called the range of given data. Here the range of the given data is 91. Meet Mr. Pinch Hitter. Sadly, he's not in the best of forms this season. Here he goes again for a duck. Have a look at his scores in the last 15 innings. Can you immediately notice how many ducks he scored? Let us see if there is a better way to present this data. Now, on arranging the given data in a tabular form, it's clear. Mr. Pinch Hitter was out for 0 5 times in the last 15 innings. He got out after scoring 2 runs in 2 innings, 9 in 1 innings, and so on. Note the second column on this table shows the number of times a value occurs in the given data. This is called the frequency of that value of data. For example, here the frequency of 0 is 5 and the frequency of 16 is 3. Remember, this table was created to present Mr. Pinch Hitter's scores in the last 15 innings. Since this table shows the frequency of different values in given data, it is called a frequency distribution table. The frequency distribution table shown here gives the frequency of each individual value in the given data. It is called an ungrouped frequency distribution table. Is there any other type of frequency distribution table? Let's find out. Now, consider Mr. Pinch Hitter's scores in the last 45 innings. If we make a frequency distribution table like the one we made before, it would be a long table and difficult to read. When we deal with large amounts of data, we create what we call grouped frequency distribution tables. Let's take a look. Now, what have we done here? We have grouped the scores into classes like 0 to 9, 10 to 19, and so on. Note that this table does not show a frequency of individual values of data, but of groups of values. Each group has a fixed number of values. A table that shows the frequency of groups of values in given data is called a grouped frequency distribution table. You can see from this table that Mr. Pinch Hitter has reached scores in the 40s 10 times in the last 45 innings, but hasn't hit a half a century. Guess he needs more net practice. Okay, coming back to our grouped frequency distribution table. The groupings 0 to 9, 10 to 19, and 20 to 29, etc. that we use to group the values in given data are called classes or class intervals of the frequency distribution table. Note that each of these classes contain a fixed number of values, which is 10. The number of values each class contains is called the class size or class width. Now look at a particular class. Say the first one, 0 to 9. The lower value in a class is called the lower class limit, while the higher value in the class is called the upper class limit. Can you identify the lower and upper class limits in the class 0 to 9? Yes. 0 is the lower class limit and 9 is the upper class limit for the class interval 0 to 9. Tally marks are also used to represent frequencies of different values in a frequency distribution table. The mean of a given set of values is represented by the expression shown here. Here x with a bar over it represents the mean of n number of values. xi with a summation sign denotes the sum of values of x from its first to nth value. Let us apply this equation to Mr. Pinch Hitter's case. In both methods that we have used so far to calculate the mean, to find the middle score, we arrange his scores over 15 innings into ascending order. Now, let us find the value that lies in the middle of these numbers. In this case, we see that this value is 9. The value that lies in the very center of a given set of values arranged in ascending or descending order is called the median of the given data. If the number of the given values is odd, as in this case 15, the median is given by the formula shown here. By the formula, the median of this group of values is the 8th value or the number 9. Now suppose we were considering Mr. Pinch Hitter's scores of only 14 innings. Let us see if the median remains the same. We see that there is no middle value here. How do we find the median in this case? If the number of the given values is even, as in this case 14, the median is the mean of the two middlemost values, which is given by the formula shown here. By the formula, the median of this group of values is the mean of the numbers at the 7th and 8th position of 5.5.
We have seen what absolute value of a number means. What is the absolute value of -3? It tells us the distance of -3 from 0 on a number line. As -3 is 3 units away from 0, its absolute value will be 3. And what about the absolute value of 3? The number 3 is also 3 units away from 0. The absolute value of 3 will also equal 3. The absolute value of -29 will be 29. The absolute value of -120 will equal 120, and so on. But now I want you to pause the video for a bit and think about one real-life application of absolute value. Just one. If you have not thought about it before, it's okay. Most haven't. Let's say you're based in Kansas. You have New York 1,500 miles to the east and California 1,500 miles to the west. One day, you decide to meet your friend in New York. You leave in the morning, and after having covered around 400 miles, you get a phone call. You stop your car and answer the call. Wow! You've been called to Mountain View, California for an important meeting. You decide to rush towards California. It all goes well, you finish your meeting in California, and then you're on your way back home. After covering around 600 miles, you decide to stop for lunch. And then you start wondering about two things. First, how far away from home are you placed? Which means, how far are you from Kansas? And second, what's the total distance you've covered? Yes, how much distance have you covered in traveling back and forth? Let's note down the sequence of events assuming your home as the reference point. First, you traveled 400 miles to the east. This distance is 400 miles. And then from this point, you travel to California. What would be the distance from this point to California? It would be this distance plus this distance. That would be 400 plus 1,500, 1,900 miles towards west. And from California, you traveled 600 miles to the east. This distance is 400 miles. This entire distance is 1,900 miles. And this distance is 600 miles. Let's talk about the first question that came to your mind. Where are you in relative to Kansas? To understand that answer, think of this as a number line. A number line in which east is positive and west is negative. 400 miles to the east will be positive 400. Then 1,900 miles to the west would be negative 1,900. And 600 miles to the east would be positive 600. What would these numbers add up to? East is positive, so we write 400. As west is negative, we subtract 1,900. And then add 600 again as it's in the positive direction. 400 minus 1,900 plus 600 will give us minus 900. What does minus mean in this particular example? It's west. So your relative position will be 900 miles to the west of Kansas. Relative position needs to include the direction. I cannot say that your relative position from Kansas is just 900 miles because it could mean 900 miles to the east also. So your relative position from your home is 900 miles to the west. The second thing you were wondering about was the total distance you have traveled. How would you find the total distance you traveled? I want you to pause the video and work through this. Yes, to find the total distance you covered, you would ignore the direction. You traveled 400 miles up to this point, then 1,900 miles to California, and 600 miles to this point. The total distance would equal 400 plus 1,900 plus 600, which is equal to 2,900 miles. Wait a moment. What exactly did we do here? What we did here unknowingly was that we found the absolute value of each number. Yes, we ignored the sign and simply added the three numbers. So yes, a car's odometer uses the absolute value concept.
Statistics, what it means? It is a collection of data and presentation of data, isn't it? So the statistics can be divided into, as I told you, first one is data. That is primary data and secondary data. In your lower class like 7th and 8th standard you would have studied. And second one is measures of central tendency. So in this measures of central tendency, we will be dealing with 3M. What is 3M? Mean, median and mode. And the last one is measures of dispersion. Measures of dispersion. So under this, we'll be seeing range, quartile deviation, mean deviation and standard deviation. So a range is nothing but maximum value minus minimum value. And in today's session, we're going to see what is mean deviation in detail.
First, let us see mean deviation from the mean. Let there are n observations x1, x2, x3 and it goes on till xn having their mean x bar. The mean deviation from the mean x bar equal to summation I equal to 1 modulus of xi minus x bar divided by n, where modulus of xi minus x bar is the absolute value of the deviation of xi from x bar. If the distribution is a grouped one, then the frequency is given that mean deviation about mean equal to summation I equal to 1 fi modulus of xi minus x bar divided by summation I equal to 1 fi. Formula for finding the mean of the ungrouped data. Mean equal to sum of the observation divided by the total number of observation. So we can denote it A is equal to sigma xi by n, where I is equal to the integers 1, 2, 3 and it goes on till n. Therefore, the formula for ungrouped data is x bar equal to x1 plus x2 plus goes on till xn divided by n, and for group data x bar is equal to summation fx by n, where f is equal to frequency in each class, x is equal to midpoint of each class and n equal to total number of scores. Next, let us see median. Mean deviation from the median. Let there are n observations x1, x2, x3, x4 and it goes on till xn having their median denoted by md. Then mean deviation from the median is summation modulus of xi minus m divided by n, where modulus of xi minus m is the absolute value of the deviation of xi from m. If the distribution is a grouped one, if frequency is given, then the mean deviation about median is equal to summation I is equal to 1 fi modulus of xi minus m divided by summation I is equal to 1 fi. Let's see median of raw data. The formula is arrange the raw data in ascending or descending order. If n equal to number of variates in the data, then if n is odd number, then the formula is n plus 1 by 2th observation. If n is even number, then the formula is 1 by 2 n by 2th observation plus n by 2 plus 1th observation. Next, we'll see the formula for finding group data. X bar equal to lower limit plus n by 2 minus cumulative frequency divided by frequency, where h denoted width of the class, or else you can write h, where L is equal to lower limits and CF is nothing but cumulative frequency, F is the frequency of class containing median, C or h is equal to width of the class, and n is equal to number of sample.
Exercise 15.1. First, let us see question number 2. What is given? Find the mean deviation about the mean for the following series. The series are given 38, 70, 48, 40, 42, 55, 63, 46, 54 and 44. So first we are going to find out the mean deviation about the mean can be calculated by using the formula summation. We are going to use the formula summation mod of xi minus x bar. X bar is nothing but arithmetic mean divided by n, where n denotes the number of series. So for that, first let me find out x bar. So what is x bar, children? In your lower classes you would have studied, it is nothing but arithmetic mean. Sum of the observation divided by the total number of observation. So sum is nothing but 38 plus 70 plus 48 plus 40 plus 42 plus 55 plus 63 plus 46 plus 54 plus 44 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here the sum of the series, the total number of series are 10. Now shall we add 38 plus 8, 8, 16, 16 plus 4, 20, 20 is 0, 5, 5, 9 is this 500 divided by 10, where 0, 0 get cancelled and we got the x bar value as 50. So what is my x bar? X bar is equal to 50. Next, shall we substitute in the formula? Now what is given in the formula? Modulus of xi minus x bar, where xi is nothing but the number of series. Xi is nothing but number of series. So series are 38, 70, 48, 40, 42, 55, 63, 46, 54 and 44. 1, 2, 4, 6, 8, 10. Okay. Now next, modulus of xi minus x bar. So already you know what is your xi, series are given, and what is your x bar? Already you found the value of x bar. So modulus of 38 minus 50. So what is the value? 38 minus 50. Always you remember, children, if the values are inside the modulus, suppose if it is in the negative side, inside the modulus it becomes positive. So here 38 minus 50 is minus 12 modulus. So what is your value? Minus negative value becomes positive. And 70 minus 50. So here 70 minus 50 is 20, positive. So you can write 20 as such. Then modulus of 48 minus 50. So which is the greater value? Minus 2. Modulus of minus 2 becomes 2. Then 40 minus 50 is modulus of minus 10 is equal to plus 10. 42 minus 50 is 8. Modulus of minus 8 is 8. So 55 minus 50. So modulus 5 is nothing but 5. Then 63 minus 50. Modulus is 13, positive. Then 46 minus 50. It is in modulus. 46 minus 50 is 4. 4. Then 54 minus 50 is equal to 4. 4. Then 44 minus 50 is equal to, what is 44 minus 50 is equal to 6. So again it is modulus 6 is equal to 6. What is summation xi? It is, you can take summation xi is 500, and here summation modulus of xi minus x bar. So when you add, how much you are getting? 10, 20, 25, 28, 30, 34, anything else? 4, balance 3, 5, 6, 7, 8. So 84. Summation xi minus x bar is equal to 84. Now what? Finally you have to substitute this in the place of mean deviation. So mean deviation about mean is equal to sigma xi minus x bar modulus divided by n. So what is the value? 84 divided by number is 10. So 84 divided by 10 is 8.4. Therefore, the value of mean deviation is 8.4. Finally, you can conclude, therefore, mean deviation about mean is equal to 8.4. Let's see question number 3. What is given in the question? Find the mean deviation about the median for the following data. So first what you have to do, arrange the given observation in ascending order, because usually for median we will be arranging from ascending order to descending order, isn't it? So first you have to arrange it in the order and then calculated the median. After the mean deviation about the mean can be calculated the relation. So here we can use the formula summation xi minus capital M, this D is nothing but median divided by number of terms. This formula only we are going to use. So first let me arrange it in the ascending order. So ascending order, first is smaller number is 10, comma 11. How many 11? 2 11 is given, 10. Then 12, only 1 12. Then 13, 2 13s are given, 13 and 13. Then 14, one value. 15 is given, children? No, 15 is not there. 16 is again 2. 16. Then 17, 2 17. Then 18. Anything else? So 2, 4, 6, 8, 10, 12. So the number of observation is 12. So it is even number. If it is even number, what is the formula median? Median is equal to n by 2 term plus n by 2 plus 1 term divided by 2. Isn't it? So what is my n here? 12 by 2 term plus 12 by 2 plus 1 term divided by 2. So 2, 6 and here 2, 6. So here it is 6th term plus 6 plus 1, 7th term divided by 2. So what is my 6th term here? 1, 2, 3, 4, 5, 6 and 7. So 13 plus 14 divided by 2. So 4 plus 3, 7. 1 plus 1, 2 divided by 2. 27 by 2. 1s are 2. 7, 2 3s are 6. Balance 1. 2 5s are 0. 2 5s are 10. So what is the median value here? 13.5. Now we got the median as 13.5. Isn't it? Now I am going to use in the formula. Summation modulus of xi minus median divided by n, where you know n is 12 observation and the xi is nothing but the series and we got the median. So shall we substitute in the formula? Let us write xi, the number of series 10, 11, 2 11, 11, 12, 13, 13, 14, 16, 16, 17, 17, 18. So 2, 4, 6, 8, 10, 12. So 12 values are there. Then what is the next step? Modulus of xi minus MD. MD is median. So what is my xi here? Xi is nothing but 10. And what is the median we found? Median M is equal to 13.5. So median M is equal to 13.5. So what is the value? Modulus of minus 13.5 is minus 3.5. Nothing but, since it is in the modulus, it is 3.5. 11 minus 13.5. So 11 minus 13.5, 13.5 minus 11 is, so here 2.5. 2.5, and again 11 minus 13.5 is equal to 2.5 again. Then 12 minus 13.5 is minus 12 minus is minus 1.5 is 1.5. So here also you will be get minus 2.5 minus 2.5. Since it is in the modulus, it becomes positive 2.5, positive 2.5 and positive 1.5. Here it is 13. 13 minus 13.5 is 0.5 is nothing but 0 plus 0.5. 13 minus 13.5 is 0.5, again 0.5. 14 minus 13.5 is again 0.5 modulus 0.5. Then 16 minus 13.5 is 5 minus 3 is 2.5. So 16 minus 13.5 is equal to modulus of 2.5 is 2.5. Then 2 16s are given. 13.5 is 2.5 is 2.5. Modulus of 17 minus 13.5 is, modulus of 3.5 is 3.5. Again you have 17 minus 13.5 is 3.5 again. And 18, modulus of 18 minus 13.5 is equal to 4.5. So when you add all the values, you will get modulus of xi minus md. So what you are getting? 10, 20, 30, 40, 50, 60, balance 6, 3, 5, 7, 8, 10, 12, 15, 18. So you will be getting 28. So 28.0. So after decimal we will not take. So it is 28. Now shall we substitute in the formula? So median MD is equal to mean deviation about median. Mean deviation about median is equal to summation xi minus md by n. So what is my xi? Modulus of xi minus md is 28 by number of n is equal to 12. 2, 4, 6, 8, 10, 12. Now 2 6 are, 2 14s are, 2 1s are, 2 4s are. Again 2 3s are, 6 2 7s are. So 7 divided by 3. 3 2s are 6, balance 1. 3 3s are 9 and it goes on 2.333. It is goes on. Therefore mean deviation about mean is 2.333. It goes on. Therefore the value is 2.3333. Now let us see question number 5. What is given in the question, children? Find the mean deviation about the mean for the data in the following tables. So here xi and fi values are given. We have to find the mean deviation about mean. So first of all, find mean using the formula x bar is equal to sigma fi xi divided by sigma fi, and then you have to calculate the mean deviation about mean. So first, already the values are given in the question, xi and fi. First let me find out how to find out x bar. X bar is equal to sigma xi fi xi divided by sigma fi, isn't it? So first let me find out the value of fi. When you add, how much you are getting? 7, 10, 10, 20, 25. So here this is sigma fi is equal to 25. Now let me find out sigma fi xi. Multiply 7 5s are 35, 10 4s are 40. So 15 into 6, 5 6 are 30, balance 3, 6 1s are 6, plus 3 is 9, 3 2s are 6, 0, 5 5s are 25, balance 2, 5 2s are 10 is 125. So when you add 5 plus 5, 10, plus 1, 10, 20, 20, 10, 20, 23, 25, balance 2 is 350. So the value is 350. Now x bar is equal to 350 by 25. Now 5 tables shall we cancel? 5 5s are 25, 5 7s are 35, 0. Then 5 1s are 5, 5 1s are 5 4s are. So it is 14. 5 1s are 5 14s are. So what is my x bar? X bar is equal to 14. Now we are going to find out modulus of xi minus x bar. So modulus of xi minus x bar. What is xi? 5 minus 14. So directly I am going to write, because already we have seen the last class with the modulus. Now directly I am going to write the answer. 5 minus 14 is 9. Then modulus of 10 minus 14 is 4. Then what is xi? 15 minus 14 is 1. And 20 minus 14 is 6. Then 25. So modulus of 25 minus 14 is equal to 11. Here what is given? Fi into modulus of xi minus x bar. So what is my Fi value? 7 into 9, 63. Then 4 into 4, 16. Then 6 into 1, 6. Then 3 into 6, 18. Then 5 into 11, 55. Now shall we write the formula? What is the formula? Mean deviation about mean. Mean deviation about mean is equal to summation Fi modulus of xi minus x bar divided by summation Fi. So where you know what is your xi is 25. Now you have to add the values of 63, 12, 12 plus 8, 20. So 30, 35, 38. So 8, 8, balance 3. So 6, 9, 10, 10, 15, 15. It is 158. So summation Fi xi minus x bar is equal to 158. Now we'll substitute here 158 divided by 25. So already the values are given. Summation Fi modulus of xi minus x bar divided by summation Fi is 158 divided by 5. Will it go in tables? No. So shall we bring it in? For the simplification you will get 25. So 25 into 6. 5 6 are 30. 6 2s are 12. 13 14 15. So 6 are 150. Again 24 into 3. 5 3s are 15. 3 2s are 6. 7 75. 3 75. 5. Again 0. It will go in. 5 2s are 10. 2 2s are 4. 5. It is 6.32. So mean deviation about mean is 6.32. I repeat here, mean deviation about mean is given where xi value and fi values frequency and the class marks are given. You are going to find out fi xi, that is mean x bar is equal to summation fi xi divided by summation fi, isn't it? So first you have to find the value of frequency and the summation fi xi, add the values. So you will be getting 350 divided by 25. Your x bar arithmetic mean is 14. Now let me substitute the value of mean deviation about mean. So you are going to find out. For that the formula is summation fi xi minus x bar modulus divided by summation fi. So when you take xi minus x bar modulus, you will be getting the values of 9, 4, 1, 6 and 6, 11. After that you have to multiply with the frequency f of I into modulus of xi minus x bar. You will be getting the value as 158, and after that you have to substitute in the formula. You will be getting the mean deviation about mean is 6.32. I hope today's concept is clear. We'll continue the remaining problem in next online session. Thank you, children.